it is observed that hypothesis testing can be done with the help of SAM. That is very fine. That is fine, not a problem. But the hypothesis should come from the literature support. If you don't have strong literature, SAM should not be applicable. So in that session of it, in that pre-submission, the hypotheses were rejected by the panelist and asked the scholar to find out the valid or enough literature support to form the hypothesis and then go for application of the structural equation modeling. So first thing which you should remember, SAM is a technique. SAM is a technique and it is used for hypothesis testing and theory testing. So basically this word is wrong because tools normally we call for softwares. So SAM is the most popular technique for hypothesis and theory testing. Now this is fine. If you don't have existing theory, don't go to SAM. Now in this diagram, this is just one of the example of structural equation modeling. In this diagram, I have to explain the diagram first. In this diagram, there are these circles, right? So these are the circles, and these circles are known as construct. And number two, so I hope you know what is the construct, number one. Number two, you can see that all the constructs are connected to some small boxes like this, right? So all these small boxes. So these small boxes are known as items, or items is a popular name. Otherwise, they are the statements. And these statements you have in the questionnaire. So statements or the items. So these statements or the item are the part of the questionnaire, and you have the data of that. Right. So number two, these small boxes are the items or the statements. Number three, if you see the arrow of all the constructs are emerging from here, and you can see the direction of the arrow and the connected with the items. So when the arrow emerges from the construct, this is called reflective construct. This is known as reflective construct. And in case if the arrow come from the items and connect the construct, so here you can see the direction of the arrow is opposite. Here the direction of the arrow is from construct to the item, and here the item to the construct. So this is called formative construct. So in this case, we can say the items have an impact. Items are having impact on the construct, and here construct is having the impact on the items. So there are two types of construct: formative construct and the reflective construct. In this diagram, all the constructs are reflective in nature. So this is known as reflective structural equation modeling. Okay, now this portion of the model is known as inner model, and this portion is known as outer model. So we have inner model, outer model. So inner model is simply the arrow between the construct. This arrow between the construct is counted in inner model, and the arrows between construct and the item is the part of outer model. And whatever number you are seeing here, all these numbers, this number in the inner model, is known as path coefficient. So the number in the inner model is known as path coefficient, and these numbers, you can see all these numbers. These numbers are known as construct loadings. Construct loadings. Okay, and these small circles are the basically error terms. Error terms, right? So this is the nomenclature of a structural equation model, and we will use this nomenclature frequently. Formative construct, reflective construct, error terms, items, the constructs, and the path coefficients. So these numbers are the path coefficients, and these numbers are the outer loadings or construct loadings. So this is the different nomenclature we use in the structural equation model. Okay. Now, first of all, I want to tell you some of the theories which are very popular in structural equation modeling. The first theory, which is explaining the consumer behavior, is the theory of planned behavior. So if you are planning to study the behavior of the consumer, for example, recently I handled many projects on this. Like one of the project is impact of the consumer, impact of the intention to use in case of e-commerce, right? So the scholar want to study the consumer behavior in the case of online shopping. Nowadays you know that online shopping is one of the popular topic in marketing. So if you want to study the consumer behavior in any area, online shopping is just one example. This theory is applicable. So this is intention to purchase. This is the actual purchase, and the intention to purchase is coming from the attitude of the person, subjective norms, and the perceived behavioral control. So in this case, the one thing I am also telling you, this variable behavior, we call it endogenous or dependent. Basically we call endogenous. Dependent word we don't use, but for layman I am explaining you, this is the independent construct or endogenous construct, and this construct we call mediating construct because it comes in between. So it is mediating construct, and all these are the construct, and they are measured by some of the items. So intention to buy is a mediating construct, and these three are known as exogenous construct. Exogenous construct. So this is the nomenclature of these different construct: mediating construct, endogenous construct, and exogenous construct. Exogenous is simply means independent variable. Like independent variable we have in the regression model. So we call these exogenous construct. They are independent. And there are two types of arrows here. Basically, this arrow is a straight arrow, one-sided arrow, and this is a double-sided arrow. You can see it is a double-sided arrow, right? Double-sided arrow. So single-side arrow is representing you the cause and effect relationship. It is cause and effect relationship. And this double-sided arrow is known as correlation. Correlation. So cause and effect relationship is examined by the single-sided arrow, and the correlation is examined by the double-sided arrow. And in most of the reviews, whenever we send the article for publication, the reviewer want you to add all the exogenous variables by the double-sided arrow. So this is one of the mandatory condition in structural equation modeling, that all the exogenous constructs should be corrected by the double-sided arrows. Okay, so this theory is known as theory of planned behavior. Now I'm showing another theory. This theory is known as technological acceptance model, or TAM. So whenever you want to analyze the adoption of the technology by the consumer, for example, I know that the TAM theory was highly applicable in case of internet banking and mobile banking, or the even people or scholars are applying it for in online education technology. So whenever you want to analyze the technology adoption, you want to study the behavior of consumers adopting the different technology, like internet banking is also a technology, mobile banking, and online shopping, even website, also website interaction, and online, then even social wallets, e-wallet is also I know that many people are applying the TAM on e-wallet. So basically this is the attitude about using. So what is the attitude? And these are the exogenous variable, external variables. They have a impact on perceived ease of use, perceived usefulness, attitude toward using, behavioral intention, and actual use. So this model, which is based on the SAM model, is explaining the behavior of consumers in adoption of the technology. Although this is a old model, we have a new model. I will show you that model also. Now this is another theory. This is called theory of reasoned action, right? So this theory is also applicable in consumer behavior, and the consumer, it is a slightly extension to the theory of reasoned action, so theory of planned behavior. So this theory is also applicable in structural equation modeling, where behavioral intention, subjective norms, and attitude are coming from some. Basically, in this model, if you see this model and this model, there is a backward explanation of the attitude and the subjective norms. And this attitude is same, subjective norms, behavioral intention, and behavior, actually behavior. So this is a backward extension of the theory. Is known as theory of reasoned action. So you are explaining the reason of the behavior of the people. So here the focus is on explaining the reason. Then this is the most popular theory which is emerging in last few years, and this theory is known as UTUT model, and there are different versions of UTUT model, and this version is the latest version or modified version of the TAM, technology acceptance model. So in this theory, this is also applicable on the technology adoption. So behavioral intention of using the technology and continue to use the technology is my dependent variable. This is called endogenous. This is called mediating. It is a mediating because it comes in between, and these are the purely exogenous, and all these variables are called moderators. Because the adoption of technology depends upon the gender, depends upon the age, depends upon the experience, and voluntariness of use. So these variables are known as moderators. So we have the mediators in this, moderator in this, endogenous and exogenous. So this is a complete package of the structural equation modeling, where you are applying each and everything in the model. Okay, so these are some of the models I'm showing you, which I actually applied in some of the projects. So these are the different diagrams, right? And all the diagrams are coming from the theory. Like this is nothing. It is a UTUT model. This is basically the behavioral intention. We are analyzing the different factors influencing the mobile banking and their impact on behavioral intention. Okay, this is Another thing, this is the theory of reasoned action. Theory of reasoned action. So all the models are based on the theory, and I just show you 3 or 4 theories which are very popular in nowadays. And now, and so let's discuss something on the SAM. So what is actually the SAM? SAM is a procedure. You just read the lines. SAM is a procedure for estimating the series of dependent relationship among a set of construct represented by multiple measured variable and incorporated into an integrated model. So three important keywords I highlighted. Number one, dependence relationship. So if you want to analyze the relationship between the construct, like this is the relationship between the construct, we studied through SAM, and we studied the relationship between the construct. This is the construct number one, this is the construct number two. Relationship between the construct, and these constructs are represented by a number of items. So that concept is called structural equation model. And in structural equation model, there are two things. This part is known as regression part, and this part is known as factor part. So we are applying the mix of two things here in SAM, factor and regression. So the principles of regression and the factor analysis provide a foundation for understanding the SAM. Right. So you must understand what is the concept of regression and what is the concept of factor analysis in order to understand the structural equation model. And there is a lot of confusion in the market, the scholars, that sometimes they don't know SAM, so they go for regression model. But actually it is wrong. You can apply a regression model when you are having the variables. When you are having the construct, you are not allowed to apply the regression. Rather, you should go for the structural equation model. So you should know what is the difference between a structural equation modeling and multiple regression. In multiple regression, you can see that there is only one dependent variable and many dependent variables. But in SAM, you can use many endogenous and many exogenous variables in one single model. So in multiple regression model, multi-collinearity is not a big problem, but here we are allowed to correlate the constructs in between. So we can put the correlation by double-sided arrow between the construct, between the exogenous construct, to capture the multi-collinearity, if any. And basically, this correlation also helpful in increasing the model fitness. So this is also good for the model actually. And regression, we apply OLS model. Linear model, we assume that the model relationship is linear. But in structural equation modeling, we assume that the linearship is non-linear, and to capture the non-linear relationship, the method used for applying structural equation modeling is maximum likelihood estimation. So we apply maximum likelihood estimation method to calculate the parameters in SAM. So whenever we want to apply the SAM, these are the different steps in the procedure. So let me discuss one by one. First of all, you have to design and finalize the individual constructs. So every construct you have to examine, and then you have to go for the measurement model. Measurement model is known as the validity of the model, validity of the scale. So CFA is used to examine the scale and check reliability and validity with the help of the measurement model. After that, you have to examine the common method bias. So because as you know, reliability is normally we test it in the data analysis. Similarly, we have to go for validity. Similarly, you have to apply for SAM, CMB. CMB stands for biasness. You want to know what is the level of biasness in the data. So are your respondent biased, or your respondent are not biased? So you can check the biasness by common method bias. And in case if your data is biased, it means whatever results you are drawing are the biased results. So we are not interested in drawing the biased results. So we have to find out the actual results So for that, you need to examine the common method bias. Then we examine the structural model, a structural model, and do the hypothesis testing. And then we go for structural model validity, means whether the theory is supported by the model or not. So this kind of validity is known as nomological validity. And eh, after analyzing the structural equation model, we have to test whether theory is supported by our model or not. So then you can make conclusions and all. So this is the step which I am going to follow just now, and will explain you each and everything in the process. These are the two arrows as I explained. The single side arrow is known as prediction. We are doing this cause and effect relationship, and the double side arrow is called correlation. Now there are some assumptions of SAM. So you have to examine whether these assumptions are fulfilled or not. So some of the concept which we normally check in SAM is, number one, we have to check whether the scale is multivariate normal or not, whether the data is normal or not, because you know that you can apply any of the parametric test only when the variables are normally distributed. If your variables are not normally distributed, there is no point of applying parametric studies. Similarly, in SAM, this is one of the assumptions that your data should be normally distributed. Then we can check the cause and effect relationship, whether they are significant or not. And we also apply correlation between exogenous construct, whether they are significant or not. And then we check whether possibility of modification is there or not. Then model fitness. Now basically all these concepts I am going to explain you with the help of example. So I will tell each and every step. I will go for this model. So just I am showing you this model again. So you can click a photograph of this model, because we are going to, I will tell you each and every step that should be done to make this model. So kindly either you note down, or you can pick a snap of this, so that you will understand what we are actually doing. Okay, so this is the practice we are going to do. I will show you each and every step that is there to examine the structural equation model. So in this model, organization productivity is the dependent construct. This is mediating construct, and these three are, we are having the exogenous construct. And the theory behind this is that the training quality, because every organization is conducting the training and development programs, we want to see whether these training and development programs are having impact on the employee improvement, and if employee improve, that organization productivity will also improve. So it is just indicating the role of training and development programs on the employee improvement and the organization productivity. And the training and quality is also related with the selection process of the employee and the trainer, and the management sincerity, how much management is sincere about conducting the training and development programs. So this is the model, and I want to test this SEM model uh, in this workshop. So I will show you each and every step that is there to reach at this model. Okay, so now I think you know what we are going to do. So let me tell you once more. First of all, I will examine that zero construct, one zero construct I will examine. Each construct in itself is a zero order construct, Then I will check the validity of the model, validity. Then I will check the biasness, and then I will check the SAM. So these are the 4 steps I will show you in this workshop. And apart from them, there are many things, but I hope if I complete all the 4 steps in this workshop, that is enough, and you will get some understanding that what is the procedure we are doing in this. Okay, so I am coming back to the model. So before that, one thing I want to tell you, yeah, that is very important. There are 2 types of SAM. You should know there are 2 types of SAM. One is known as covariance based SAM, covariance based SAM, and this is known as CBSAM. CBSAM, on this is called PLSM. So there are two types of SAM, covariance based SAM and partial least squared SAM. This method is can be tested with the help of a software called Hemos, and PLSM can be tested with the help of Smart PLS. So Smart PLS. So these are the two softwares which we are going to use today. I will show some of the one example in Smart PLS also, and one example in Hemos also. So I will use both the softwares today for demonstration. And now one thing you may ask about that, where to use PLS and where to use CBSAM. So PLSM we used when we are having the small samples, number one, and number two, when you are having formative construct in the formative or formative and reflective, or only formative, right? And this Hemos is used for examining the reflective construct. If your SAM is based on a reflective construct, then you go for Hemos. If you have large sample size, then you can apply Hemos. So reflective and large sample size, we go for Hemos. Small or formative, we can go for Smart PLS. So now I am showing you the Hemos first, then I will show you the PLSM. Okay. So now I will go slow because I know that I'm moving a little fast, but I want to give more time to the practice. So I am showing you the new file. Yeah. So when we open the Hemos, it is a new file, and on which we are working. So first of all, we have to attach the data, because Hemos is a sister software of the Hemos, SPSS. First of all, we have to attach the SPSS file, and then we can proceed. So here we are having this icon. The name of this icon is called select data file. So I am clicking it, and I am attaching the SPSS data file. And this SPSS data file I have in the workshop folder, Hemos training and training data. So this is my data, and I am using this data set. So in training data, you can see that there are 300 observations, and this n means number of observations. So number of observations I have is 300, and okay. So if you want to see the variables in the data set, you can click here. This is the another icon which is called list variable in the data set. So we are having number of variables in the data set. All the variables you can see here. So first of all, I will examine any one construct. Like for example, now I hope you understand what is the meaning of the construct. So this, I'm using this icon for designing the construct. The name is that draw a. Okay, so I'm taking this icon, you can see here, and this is the white space in which I will make the diagram. So let me draw it. And suppose I want to make E1 to E5 first. So there are 5 items in it. So I make 5 click, 1, 2, 3, 4, 5. So there are 5 items in the construct. So let me rotate it. This icon is used for rotation. You can rotate like this. And then I want to keep this diagram symmetrical. So I will click on the C10. This is the 10th icon of the C third column, and I will use this truck. जैसे truck घूमता है तो ये भी घूमता है हमारा. So we can move the diagram using the truck. Similarly, we are having the shape changer. So if you want to change the shape, you can change the shape like this. So we can change the shape like this, and so these are the instruments which are used to make the diagram clear. And I want to analyze the first zero order construct. So this construct is basically the zero order construct. And these are the items which we have in the questionnaire. And let me.
So I think your video has stuck.
Sorry.
So video, there is some issue with your video. It is not. I mean, it
Not
has
showing
stuck.
Hemos, sir.
Okay. So let me
It
check.
is not showing Hemos, sir. It is just showing the SEM is most popular technique slide 2, sir.
Okay. I got it. Okay. Now let me start from the beginning. Okay. Thank you for reminding me.
Yes, sir.
So I am going to open a new file. So I hope you can see my new file. Yeah, I examined. So this is a new file, and this is Hemos. And I am showing you the model building, how to develop the model from step number 1, step number 2, step number 3. So in this session, I am going to show you the 3 things. Number 1, first of all, I will show you the how to analyze a zero order construct, and then I will show you the validity of the construct, and the third I will check the biasness of the construct. So 3 steps I will do in this session, and in the next session we will see the structural equation modeling. Okay, so this is the process I will discuss. So sorry for not sharing the screen, and I'm starting from the beginning. So this is my blank page of the Hemos. So first of all, I have to go to the data, select data files, and go to the file name and the software, because you have to attach the data file with it. So I am looking the data file. Data file is there in the folder workshops, Hemos training, and training data. This is my data. After attaching the data, you can see that there are 300 observations in the data file. So sample size is 300. Okay, and I can see my all the variables here. You can see all the variables now. I can see here. So I will use this diagram. This diagram is called C1, the first diagram. So I make the 5. Now you can see that this, with the help of this icon, I make this diagram, and I want to rotate it. So for rotation, this is the circle, rotate it, and after the rotation, I want to move it. So you can use the truck for the movement. Yeah, you can, now you can see that you can move it. After that, let me drag and drop all the variables. So I am just dragging and dropping each variable. Okay. Now because the statements are too lengthy, so I want to remove the lengthy statements. So we have a facility in view, interface properties, and miscellaneous. If I click on this, the only variable name comes here, and you can see only the variable name. So we call them item code. Normally we put item code in the rectangles. We don't put the complete statements. And after that, I'm going to plug in. So because I have to fill all the empty circles. So in plugin, we have a facility called name unobserved variables. Now you can see that all the numbers here, and F1 is the name of the construct. So basically the actual name of the construct is organization improvement. So I should write organization improvement. Okay. Now if the whole diagram is over, complete, fine. Now I want to analyze it. So I'm showing you how to analyze it. This is the second icon of the second column, and this icon name is Analyze Properties. I click on it, and very important option here is output. So you can see that in the first row we are having a option called output, and I have to select few things here. So like standardized estimates, I want to see a squared multiple correlation, I want to see correlations, I want to see then normality. The most important is normality. Normality I want to check. So let's run it. If you want to run it, first of all you have to save it, because before saving you cannot run it. So first of all I want to save it in my desktop. The name is zero order. It is a zero order construct, so I put it 0, and after that I can run it. So if you want to run, you have to click on calculate estimates. Now you can run it and go to the output. So from here you can go to the output. Now output is in front of you. So the number one, first of all you go to assessment of normality. Assessment of normality. In assessment of normality you have to check two things. Your skewness and kurtosis should be less than 0.5. I repeat, your skewness level and kurtosis level should be less than 0.5. So all the skewness and kurtosis are less than 0.5, so some normality is there, and all the critical ratios are less than 1.96, so it is a fine, no problem at all, and we can go to the estimate after that. This is the most important option, estimates. In estimate, the first table is regression weight, and this table is showing you whether all the items are significantly representing the construct or not. So you can see all the p values are significant, all the critical ratios are more than 1.96. So we can say that all these statements are significantly representing the organization improvement, because all the p values are significant and all the critical ratios are more than 1.96. And the second table is showing you the this is called loadings, construct loadings. The second value is known as this is construct loading, and this construct loadings should be greater than 0.7 but should be less than 0.9. So this is the condition of this construct loading, and we can see some of the construct loadings are even more than 0.9, so but they are in borderline, so we can accept that, and construct loading is fine. All the construct loading are more than 0.7, very good. And from this construct loading we calculate two different things, two different formulas. Like first is, if this is my suppose beta 1, beta 2, beta 3 and beta 5. So if I calculate the square of the beta 1 plus beta 2 plus beta 3 and so on, and if I divide it by beta 1 square, beta 2 square plus beta 3 square and so on, plus 1 minus beta 1 square plus so on. So this will give you the concept of average variance extracted, right? So this formula will tell you that how much the construct is representing, how much variance of the variables the construct is explaining, which should be greater than 50%. How much variance of the items can be explained by the construct. So this AVE should be greater than 50%. Second formula that we can derive here, summation of beta 1 plus beta 2 plus beta 3 and so on square. After that, summation of beta square plus summation of error. This formula gives you the value called composite liability, and composite liability of the construct should be greater than 0.7. So if these two conditions are there, then you can say your construct is a valid construct. Your construct is a valid construct. So in total we can find out CR, which is greater than 0.7, and second is AVE, which is greater than 0.5, and these number itself, These are known as construct loadings. So construct loadings should be greater than 0.7. So if these three conditions are fulfilled in a construct, we can say it is a valid construct. It is a valid zero order construct. So similarly, we have to check the validity of each construct separately, and then we can go for the complete validity of the model. So I hope this is clear to you. And after that, one more thing which I am going to tell, which is called model fitness. In this model fitness, we have to check few things. I'm writing all the few things here. Number one, you have to check this chi-square minimum value with divided by degree of freedom. Then you have to check goodness of fit index, and then you have checked AGFI augmented fitness index. Then you have to check CFI, TLI, NFI, and RMSEA. So all these are the goodness of fit index. इनका कोई मतलब नहीं होता, ये सिर्फ number है. So all the numbers have some standardized values. So kindly note that this is less than 5. This should be greater than 0.8. Should be greater than 0.8. CFI should be greater than 0.9. TLI and NFI, all the values should be greater than 0.9. RMSEA should be less than 0.08. So these are the standard values. If you have all these standard values, then your model is fit. Otherwise, there is no problem. In this case, we can check this is not good. This is good. Good. AGFI is slightly less. CFI is fine. This is also fine. This is also fine. And we can check one more value, which is called RMSEA. Yeah. So this is also high. RMSEA is also high. So we have, in this case, we are having the problem in RMSEA. So this is not good. This is not good. And all the things are fine. So in this case, we have to check what is the reason of this poor RMSEA and the poor goodness of it. Because I know the problem that is a different thing. Whenever you run some model, you will definitely get some problem in the first, so you should know how to remove it. Basically, here the problem is this high beta, this value. The multivariate normality is very high, so that is one of the problem. And skewness level is slightly high, greater than 0.5. Otherwise, kurtosis is not a problem. Okay. And these two values are also low, more than 0.9. This is another problem that I found in the model. So, and one of the problem in this data is that I'm using 5-point scale, which is other problem. So you can see that this is minimum value, maximum value. In 5-point scale, I found that the problem comes frequently. Okay, so now after analyzing this one zero order construct, I am showing you that how to analyze the full construct. So let me make it change. Okay, let me go to the next one. So now I am showing you how to check the validity of the complete model after zero order construct. So I am making one construct first. And after that, this is only one construct, because there are 5 similar constructs in the data. So I have to make 5 different constructs. Yeah, you can see that there are 5 different constructs now, and I will join all the constructs with the double-sided arrows. For that, I am using a single finger, and single finger I am taking, and this is for selecting one object at a time. After that, I go to plugin and draw covariances. So now you can see all the covariances are there. Covariances means the two constructs are connected together. So the framework is complete. Only thing I have to do is to send the variables in the boxes. So let's attach the data first. We attach the data. Data kahan pe hai? Data is in desktop. Okay, so Hemos training. training data, training. Now I'm transferring the items. So all the items are here. Will take only 1 minute. I will make this diagram in 1 minute. And here we are getting the long statements that we can reduce to the item code. That is not a problem. I will show you how to reduce the item codes. And yeah, so I complete all the items, and I go to view, interface properties, miscellaneous, uncheck this and apply. After that, you can see that we are having only the item code, not the uh, long statements. And I need to increase the size of the boxes. So I click on this, and you can see that I can click on the boxes of all the boxes in one time. So we are having this facility also, and then uncheck it. And now only thing is remaining that we are having the empty circles. You can fill the empty circles by going to the plugin and go to unobserved variables. Now you can see we are having the complete diagram, and my purpose now is to check the validity of this diagram. So let me increase the size of some of the construct. And actually there is a rule that we should not have the number in the construct name. But so I have to rename the construct once again. And because all the constructs are having the name of 1, 2, 3, 4, 5, so number should not be there in the construct name. And so now my construct looks better. And okay, so let me keep it FA. Number is not allowed. You have to keep only the alphabets: FB, FC, FD, and FE. So now I'm interested to check the validity of this construct. So if I want to check the validity, I have to download one of the important tool, and that tool you can find out in the website called Stats Wiki. Stat Wiki is a website. Yeah, you can see that there is a Jaskination website. Jaskin is the name of the professor, and he named the Jaskination on his name. So Jaskination Stats Wiki. Let's click on this, and here you can see the option called Statistical Tool Package. So I want to download it, and we'll use it for the validity measurement. So this is the basic statistical tool, and the software downloaded the tool. I'm using it, and I will use it today for testing the validity. Okay, now the tool is open. We have to enable the macro. Okay, the first option of this file is called validity master. You can see in the left hand side, left bottom, master, validity master. Now in this case, you have to cut and paste two tables from the Hemos output and click on this option. So now I am going to do that. So first of all, run it. So I am saving it first, running it. After that, you click on the output table. In output, we always go to the estimates. In estimate, the second table is known as, okay, there is some problem in it. Okay, I have to give some command. So go to the analyze properties, output. We have to check these options, otherwise software will give not the desired output. Okay, run it again. Now click on the output, estimates. In estimate, the second table is called standardized regression weight table. So I will copy this table, copy, and now paste in the here. So this is called one paste. Second paste we will do for the correlation. The fourth table is known as correlation table. I copy this correlation and paste here, and correlation aa gaya, standardized regression aa gaya. Now click on the red button. Okay, now the software is showing me that there is a lot of problem in the data set, and so let me show you what I'm looking here. Okay, so I'm showing you the conditions of examining this table. Because most of the values you can see here are red. Okay, so let me tell you what we are doing here. There are two types of validity. We are testing the validity of measurement scale. We are testing the validity of the scale. There are two types of validity. One is called convergent validity. Convergent validity, and the second validity is called discriminant validity. Discriminant validity. Convergent validity has conditions. First of all, composite liability should be greater than 0.7 but less than 0.9. AVE should be greater than 0.5. So these two conditions we have to check from here. And discriminant validity we have to check from two conditions again. Number one, the AVE should be greater than maximum shared variance, and square root of the AVE should be greater than the correlation between I and J. So now I am showing you the conditions in this table. So as I said you that we are looking the two conditions. So first, now check the value of composite liability. So composite liability, you can see the condition, this less than 0.9 condition is not there. So we can cross that this condition is not fulfilled. AVE is greater than 0.5, this condition is fulfilled. Then AVE should not be more than MSV. This condition is also not fulfilled because all the MSV are more than AVE. So this condition is not fulfilled. And here we have to check this is the square root of the AVE, and this value should be greater than all the vertical number. This value should be greater than these three numbers. This value should be greater than these two numbers. This value should be greater than this number. So this criteria is known as Fornell-Lacker criteria. And according to the Fornell-Lacker criteria, this condition is fulfilled. But we are having the problem in condition this and condition number this. So the scale is not a valid scale according to the results. So we cannot go to the SAM ideally because I found that 100% when you apply this validity testing in your data, you will get problem somewhere, right? Okay. So this is the process of testing the validity, and we are having some problems in the validity as you can see in the results. Now, if you note it down all these things, you can see that most of the values are red. If values are red, it means we are having a problem. So we are having the problem in this. We are having the problem in discriminant validity. So you can check here. So the problem we are having in the discriminant validity. Discriminant validity is not found in the results. And another problem which the software is not telling you, but the problem is there. This composite liability value should be less than 0.9, greater than 0.7, but less than 0.9. So this process is called the testing of the validity problem. After validity testing, okay, okay, now let's minimize it rather than closing. Now I'm going to the third step, examining the biasness of the scale. So I'm telling you the biasness from the CMB method. So I will take 5 minutes for making the diagram and then tell you how to check the validity also, biasness also, sorry. And now I'm going to check the biasness from a method called CMB method or latent factor method. So I'm demonstrating the latent factor method now, and just I will take hardly 2 or 3 minutes in making the diagram. Just see. So suppose I am making this diagram, this blank circle, and this blank circle I am making to capture the biasness in the data. So that's why I keep its name biasness, right? Biasness. So now I'm going to capture the biasness in the data. So just see what is the process. And the maximum variance of this biasness is 100%. So I'm putting it 1. Variance is 1. You can see this 1 here. Now I connect all the I connect this diagram with the all the items, because my purpose is to capture the common variance. Common variance means the variance which is there in the all the items. So that is the indication of the biasness. So let me complete it in the next 5 minutes, so that you know that how we can check the biasness also. I hope you understand the biasness. If you are asking your student about your feedback, and a student says that you teach is excellent, so it may not true that you are really teaching excellent. It may be possible that he is buttering you. So these are the biased responses. These responses are known as biased responses. Okay. Now I connected this big circle with all the items to capture the biasness. One thing you have to do now, take any line. Like for example, I want to take this line, and this line name is X. So I am giving this name is X, and I'm showing you bold, and I'm coloring it so that you can see it clearly. Okay, so you can see this X. So yeah, so you can see that there is a X. This is the parameter I assigned to this line, and actually I want that this parameter should be there on each line. So for that there is a step. I have to touch each line. Now I am selecting the each line because I want to copy this X on each line. So if you want to copy this parameter for each line, there are two methods, either to do it manually or you can do a shortcut. So I am going to a shortcut method. By doing this method, you can copy the parameter to all the lines. So just first see, because I know that you cannot do it along with me. So better you watch it and then try to do on your own. And let me, okay. So all the lines should be blue after this. Yeah. So all the lines, I hope they are blue. Now I click on this option, and in this box, this come from here, drag properties, and let me keep it parameter constant open. and now I am double click on it. If you double click on it, you can see that all X comes in all the lines. So you can do it manually also, you can do with the help of this step also. So whatever step you follow, that is not a problem. Now I want to run it, and so let's see what will happen. And after running this model, go to the output, and let's see what is there in the output. In output, you can see that, yeah, so this value of biasness, now see all the values of biasness. This biasness value is 0.86 into 0.86. If you square it, 0.86 multiplied by 0.86, हम एक round of ले लेते हैं, 8 8 just 64, around 70%. So it means the around on an average you are having 70% of the biasness in the responses. So now what is the rule here? Thumb rule. So thumb rule is that the square of the biasness, which is 0.861 here, the square of this value should be less than 50%. It should be less than 50%. And if it is less than 30%, it is excellent. So this is the condition of excellent, and this is the minimum criteria of biasness. So we can also check the biasness in the results in the scale, and we have one more method of testing the biasness. This method is known as latent factor method. Latent factor method of testing the biasness. And now I'm going to show you the next step, which is known as a Herman single factor method of measuring the biasness. So let me show you that also. Clear, all clear diagram. Okay, now I go back to the model, and let's see the data, view data. So data will be open, data open now, and now I'm showing you the another substitute of measuring the biasness. Go to analyze, dimension reduction factor, and after that I am sending all the variables which are there in the model, and just go to the extraction, and make fixed number of factors is 1. Change the fixed number of factors to the 1. Continue and OK. So let's see what results come. Yeah. So you can see that on an average 70% is the biasness. So biasness is around 70%. So this 70% should be less than. So this value should be less than 0.5. So this factor, this method is known as Herman single factor method of examining the biasness. Herman single factor method. Herman single factor method, which value should be less than 0.5. So there are two methods of testing the biasness, but because this data is heavily biased, this data is not valid. So ideally, we should not go for the hypothesis testing or in SAM. But let's assume that everything is fine, and I'm showing you how to test the SAM also. But before moving the SAM, let me check once again what I. Okay. So we have the data. We have examined the validity. Okay. So I discussed 3 aspects in this lecture. One is I'm showing you in this slide, and after that I will take some queries to know whether you got it or not. Okay, so let me revise one thing which we did. Basically, first of all we identify the zero order construct, then we identify the CFA method, the validity, and Yeah. So zero order, and then we analyze the validity. After that, we can go to the SEM. If it is clear to you, please say yes. Otherwise, I can repeat any of the steps. Okay. If you want me to repeat any step, I will repeat. So you are saying me Herman single factor method to check biasness. Okay. So first of all, I am repeating the Herman single factor method, and then I will show you the CMB method. Good. So this is my SPSS, and I will explain you the Herman single factor method. Basically, if your data is biased, it means your results are also biased. Let me tell you one incident in 2 minutes. In one of the meetings of in one college, the director say that professor, your feedback is 1 out of 5, and if in the second term, if you get the same feedback, so we have to take some corrective action. Then professor say, don't worry sir, next give me one more term, and let me improve the feedback. So after one term, whenever the feedback comes, it was 5 out of 5. So basically, if you know what is the concept of biasness, if you manage your biasness, sometimes it is very good, sometimes it is not good, and we know that all of us are try to manage the feedback of the students. So we applied so many methods of improving the biasness. So similarly, we are having the biased data in the research, and we want to know that how much data is biased. So this is the data. I am going to analyze, go to dimension, reduction, and factor. So you can see that I'm going to back to the factor analysis, and so I am putting reset. I put all the variables here, which I actually included in the validity. In extraction, I'm giving the number 1. I want to extract only one factor. Factor to extract is only 1. I want to extract one factor. Continue, and okay. So steps are very simple, and then you can go to the next table, and this table is showing you that the biasness is 70%. The first factor is having the 70% of the biasness, and this value should be less than 50%. This value should be less than 50%, right? So this is the process of testing the biasness and validity. Okay, I hope you understand now how to check the biasness. And if I remove this, now this is the CFA diagram, and CFA diagram is to examine the validity of the scale, right? And in validity of the scale, I used the statistical tool package provided by the Professor Juskin. So if your scale is valid, then you can go further. Otherwise, you cannot go further. Okay. Now, I want to take some of the queries, because I hope there is a lot of variety in the participants, and so 15 minutes I will take query, and if anybody want me to repeat anything, I will repeat, or I will repeat in the next session. So you can put your queries in the chat box. So like Shilpi madam is asking that why the biasness is less than 50%. Okay, so I am showing you the slide of Professor Jeskin, because this is one of the source where we can quote that what is the level of yeah. So you can see that this is the common method bias here, and let me show you this factor, common factor Herman single factor method. So you can see that there is an option called Herman single factor, and Herman single factor is measured by this method, and this method should be less than 50%. So it is mentioned in many sources that this value should be less than 50%. In this case, here he is not mentioning it. Yeah, but it is available in the literature that this value should be less than 50%. Okay. Then if you give me if you allow me, I can show you in the SAM PLS also how to check the validity. Okay, so let me show you the validity in the PLS now, because as I promised, I will show you the PLS also. So this is the smart PLS software, and if I click on it, so now I am showing you the validity testing in PLS software. So this is my data, training data, and yeah. So in this case, in the SAM PLS, I delete this because I want to show you after importing the data, you can make the model itself. Let me delete this model. Just this model is the model for validity, and now I am showing you how the model building in SAM PLS, which is one of the easiest thing to do. Just drag and drop the items. Just drag and drop the items, and so in this case, I am making the model. So the model is actually the correct model is actually, this is my dependent, this is my independent, and so in PLS you have to make the model, and you can do SAM and validity in one step. So I am showing you that. Now the model is complete. When your model is complete, it becomes blue, and make some adjustment. Like I can arrange some of the movements. Yeah, this is my model, and if you go to the calculate, go to consistent PLS algorithm, and start calculation. So all the measure of biasness you can see also here. Like if I click on the construct liability and validity, so you can see all the composite liability, average variance extracted that we calculated in here, and Cronberg alpha is also coming. So Cronberg alpha of all the constructs, composite liability of all the constructs, and average variance extracted of all the construct, you can calculate like this. And if you click on discrete validity, you can see this Fornell-Lacker criteria. This is called Fornell-Lacker criteria, and we can in PLS we can also have this heterotate, monotate method, cross-loading method. So we can examine the validity in PLS as well as SAM, but the criteria is always same. So this diagonal values are known as square root of AVE, and these values should be greater than all the values, right? So we can check the Fornell-Laker criteria and all the criteria here also. The Fornell-Laker criteria, this is a heterotrait monotrait criteria. This number should be less than 5 ideally. However, in this case, some of the values are higher, so we have problem. So these are the values of heterotrait monotrait. Okay, so we can examine biasness. We cannot examine in PLS, but the validity we can examine in this also. So we are having the facility of calculating the collinearity diagnostics also. So some of the because as I said, Cronbach composite liability should be less than 0.7. So all the values should be less than also 3 for having no problem of multicollinearity. So we can check outer loadings, each and everything in PLS also. Okay. So I know that I'm moving very fast because so many things I have to tell you in one lecture, but it is always better to show more as compared to show less, right? So now now you can ask me your query, because whatever I want to show you, I already show. Okay. So selected queries I will take because I cannot take all the queries. Mukta Jain ma'am is asking that will all the tests giving the same result in PLS? Yes ma'am, all the because the value of composite liability, value of average variance expected is, and the value of Fornell-Laker criteria all are same in SAM and PLS. Okay, now okay, question answer. So I am taking some of the queries. Let me, because there are so many queries. There are 250 queries. I cannot take all these. Okay. So one query is that what is the how to get the PLS software? PLS software is you can get by downloading trial version from the net, and its trial version is available in the net, so there is not a problem. And you can buy one software, and somebody is asking for the book. I already posted the ebook in my Facebook page, so you can get from there. And can we apply SAM in finance? Yes, you can apply SAM in finance, but you must have some theoretical background, and you must have some the primary data, because recently I applied SAM in case of financial literacy problem, because there is a model which say that financial literacy is influenced by financial knowledge, financial behavior, and financial attitude. So when you want to test this kind of theory, you can apply SAM in finance also. And one question is coming that how to examine the nomological validity. Basically, nomological validity means whether your model is showing you the results as per the theory or not. So if your results are as per the theory, it is indicating the nomological validity. If your results are not as per the theory, then nomological validity is not there. And one question is coming that it's better to take 5-point or any other scale. So if you ask my experience, I always prefer 7-point scale in the primary data, because we are having a lot of variance in 7-point scale as compared to 5-point scale, and more variance means more information. In 5-point scale, the variation is less, so we have a problem of normality also. So there is a lot of problem when you apply SAM on 5-point scale. So according to me, the SAM is better for 7-point scale and less effective on 5-point scale. Okay. So some questions you are asking beyond the topic, so that I'm not answering.
Sir, there are a few questions. Can I ask you, sir?
Yeah, you can ask,
Yes,
because
sir.
I'm looking at, not able to find
There,
out.
sir, actually, these questions are from Q&A session. So the common questions are the few of them that sir, first question is, sir, how to decide on whether the construct should be reflective model or formative model, as it is so that left side construct will be always formative and right side will be always reflective construct, as you said.
There are two methods of testing whether the formative construct is there or the reflective construct is there. Actually, one is the literature support. Let's see what literature says. For example, financial literacy is a construct which is formative in nature. Formative means financial literacy is coming from the three aspects of finance, like knowledge, behavior, and attitude. So if you have three aspects, then your financial literacy will be high. So it is a kind of formative kind of thing. But so first is see the literature review whether it is formative or reflective as per the review. Then second, if you have some doubt whether it is a formative or reflective, then there is a test called confirmatory tetrad analysis. This confirmatory tetrad analysis is a technique which will tell you that whether your construct is a formative construct or a reflective construct. And confirmatory tetrad analysis you can apply in both Hemos and PLS, but in Hemos you have to do it manually, and in PLS you can calculate very easily. So in PLS, we are having an option called confirmatory tetrad analysis, which will tell you whether the construct is formative and reflective. The null hypothesis of confirmatory tetrad analysis is that the construct is reflective, and if p value is coming less than 0.05, it means your construct is not reflective, it is formative.
Okay, so the second question, operating and meeting variables.
Hello.
So what is the difference between moderating and mediating variables?
Actually, moderation and mediation are the topic outside this lecture. But I'm telling you that mediating constructs are those constructs which comes in between two different constructs. Those are known as mediating construct. And like you can see that in the theory of planned behavior, in the theory of reasoned action, the intention to buy, intention to use is a mediating variable, because it is coming between the attitude and the actual purchase. Similarly, a moderating variable like in UTUT model, you can see that the gender, age, gender, these are not the part of the model, but the model is behaving differently in uh, for male and female. Means usage behavior of any technology is assumed to be different between male and female. So when the relationship between the construct is different for different categories, that the category variable is called moderating variable. So there are two type of moderation. One is called categorical moderation, and we are having continuous moderation also. So depend upon the theory or depend upon the hypothesis, you can apply your moderation effect. I have seen the moderation effect is also categorical in nature, and moderation effect is also known as continuous in nature. So both type of moderation we can apply. Continuous moderation is also known as the interaction moderation.
Okay, sir.
And there is a
Thank you,
separate software called Process. The Process is very famous software for testing the different kind of mediation. Like in mediation also we are having different categories like serial mediation, parallel mediation, right? All the type of mediation we can examine in the Process.
okay, sir. The last question Dr. Renu asked: what is the difference between output from multiple regression and STEM?
Basically, the output of multiple regression and SAM is totally different, and ideally SAM should be applicable on the constructs and regression should be applicable on the variables. Like economics, we are having the GDP, money supply, interest rate, right? All the variables are directly measurable variables, and these are not the construct. So when you are you having the variables, you should apply the regression, and when you have the construct, ideally you should apply the SAM.
Okay, sir. Thank you, sir. The questions are over. Thank you, sir, for such a detailed explanation. In this
Thank you.
session, you have discussed about the basics of structural equation modeling, theories of planned behavior, technology acceptance model, assumptions of SAM, uh, about the latent factor method, Harman single factor method. So thank you, sir, for the session.
Your voice is
Now,
breaking, Amir.
today we will have another. Okay, sir. Today we will have another session with her at 12 noon. Before that, there is a break of 30 minutes. So we are meeting again at 12 o'clock. So thank you, sir, for taking this session.
Okay, thank
Am I
you.
audible? Thank you.